Hello everyone. So welcome to the new session of this module, that is in infinite Fourier transforms. So in our last session, we have discussed about the Fourier sine and cosine transforms along with its inverse. So in today's video, before getting started with the problems related to that Fourier sine and cosine transforms, we have one important question that we have not solved yet related to the inverse Fourier transforms. Okay, yeah, so the question goes like this. Find the inverse Fourier transform of f of s is equal to e power minus s square. Here instead of f of x they have directly given the value of f of s, that is e power minus s square. Okay, they have not given any value for f of x. So if they had given f of x, we need to find first f of s, after that inverse. So in this case directly we are going to find the inverse since the f of s value is given. Okay, so we know that the inverse formula goes like this, that is f of x is equal to 1 by 2 pi interval minus infinity to infinity f of s into e power minus isx into ds. ds is the parameter here, right? Yeah. So now let's put the value of f of s, e power minus s square, e power minus of isx into ds. So now let's add the powers, that is f of x is equal to 1 by 2 pi into minus infinity to infinity e power minus, I'll take minus common outside, and s square plus isx into ds. So now this similar kind of problem we have solved it, right? See, in the bracket s square plus isx can be replaced by some of the terms, that is I am going to write it here. We can replace the whatever is there in the bracket s square plus isx by s plus ix by 2 whole square plus x square by 4 by completing square method. Okay, so we are going to replace this term, that is s square plus isx by s plus ix the whole square plus x square by 4. So this term, when we simplify, should be equal to this term only, that is s square plus isx. So let's see that whether it's equal or not. If it's equal, we are going to substitute the value. Okay, yeah, this answer we have got it by completing square method. Okay, yeah, so now let's see. So this is of the form a plus b the whole square, right? So put the identity, that is a plus b the whole square is a square plus b square, that is I square x square by 2 square, right? 2 square is 4 plus 2ab, that is 2s into ix by 2 plus write x square by 4 as it is. Okay, so here we can cancel this 2, so the remaining terms are s square, and the value of I square is minus 1, right? So this sign changes, it becomes minus x square by 4 plus this is isx plus x square by 4. Here minus x square by 4 and plus x square by 4 gets cancelled, so the remaining term is x square plus isx. See, we've got again the same term, right? S square plus isx. So now we are going to replace whatever is there in the bracket s square plus isx by this term. Okay, so now let's further write the equation here. Minus infinity to infinity e power minus of s plus ix by 2 whole square plus x square by 4 ds. So now these both powers are getting added up, right? So now let's split them. So after splitting, it will be looking like this: e power minus of s plus ix by 2 whole square into e power minus x square by 4 ds. I have just multiplied minus to both the terms. Okay, so now we are going to take this term outside along with the constant term in order to simplify. E power minus x square by 4 by 2 pi interval from minus infinity to infinity e power minus s plus ix by 2 whole square ds. So now we are going to replace s plus ix by 2 by t. So now we are going to put s plus ix by 2 is equal to t. So now we are going to differentiate on both the sides, that is the differentiation of s is ds along with the imaginary term that is neglected. So this is an imaginary term, right, that's neglected, and in the other side the differentiation of t is dt. So now we are going to replace these values, that is f of x is equal to e power minus x square by 4 by 2 pi minus infinity to infinity e power minus s plus ix by 2 is equal to t, right? It's whole square, so t square into ds is replaced by dt. Now we know that this function is equal to root pi, right, according to the gamma function. So we are going to write it as e power minus of x square by 4 by 2 pi into root pi. Okay, we can further solve this. We can further simplify this by, here in the denominator there is 2 pi, right? So we can even write it as e power minus x by 4 root pi into 2 into root pi into root pi. I have just written pi as root pi into root pi so that I can cancel 1 pi from the numerator. Okay, so the final answer which you are getting is e power minus x square by 4 divided by 2 root pi. So this is your required f of x. Okay, this was one problem, okay, which is an important one. So now we are going to solve the problems related to the Fourier sine and cosine transforms. Okay. And so this is the first question of this topic, that is we need to find the Fourier sine and cosine transforms of the function f of x, which is given as e to the power minus alpha x, where alpha is strictly greater than 0. That is, we can say that alpha is a positive constant. So first we are going to solve it for Fourier cosine transform. I am given it as FCT short form. So the Fourier cosine transform formula, as we have discussed, is fc of f of x is equal to, interval is from 0 to infinity now, f of x, since it's a cosine transform, the function is cos sx into the parameter here is dx. Okay, so now in this we are going to substitute the value of f of x, that is fc of f of x is equal to 0 to infinity. The value of f of x here is e to the power minus alpha x cos sx into dx. So if we see this function integral very carefully, this is of the form e to the power ax cos of bx plus c, right? This function is equal to e to the power ax divided by a square plus b square into a cos bx plus c plus b sin bx plus c, right? This is defined like this. So in the same way, in place of here a we have alpha, and in place of b we have s, and the value of c here is 0 since it is not given. So in the same way we are going to substitute this and we are going to write it in the form of the given integral. Now fc of f of x is equal to e to the power minus alpha, here the value of a is minus alpha x divided by a square, that is minus alpha the whole square. So minus alpha the whole square is equal to alpha square only, right? Minus alpha into minus alpha is equal to alpha. So it is given as alpha square plus the value of b here is s square into minus alpha cos sx, that is a cos bx plus b is equal to s cos sx, s sin sx, yeah, and the interval is from 0 to infinity. Okay, so now here we can take 1 by alpha square plus s square common, and we can multiply e to the power minus alpha x to both the terms. That is e to the power minus alpha x into, use the minus sign, cos sx plus e to the power s into e to the power minus alpha x sin sx, and the limits are from 0 to infinity. So now we are going to apply the limits, that is 1 by alpha square plus s square is constant, it remains outside. Now the limits are from infinity, so e minus e to the power minus infinity, right? So alpha, now we are, in place of x we are going to write it as infinity. Infinity into anything is infinity only, into so here there is an alpha term, okay, into minus alpha. So yeah, let's make this plus and let's take minus alpha common. So here I just made the change, that is this e to the power minus alpha x is there, right? I have taken common in these two terms, okay, so that we can split the limits only for these two functions. Minus alpha cos of infinity plus s sine of infinity minus e to the power alpha x. So in place of x now the lower limit is 0, minus alpha cos 0 plus s sine 0. Okay, so we know that e to the power minus infinity is equal to 0, right? So this whole term is 0, and the value of sine 0 is also 0, so the remaining terms here are 1 by alpha square plus s square into e to the power 0 here is 1, so minus into minus is plus, so 1 into alpha cos 0, so cos 0 is again 1, so 1 into alpha, so the remaining terms are alpha divided by alpha square plus s square. So this is your required answer. This is for Fourier cosine transform, okay. So now we are going to find the Fourier sine transform. Yeah, so this is the formula for Fourier sine transform. So here in place of cos we are just replacing the parameter of sine, the rest all the things remains the same, okay. So now let's substitute the value of f of x, that is 0 to infinity e power minus alpha x sin sx into dx, okay. So here again we have the formula for e to the power ax sin bx plus c, right? That is equal to e to the power ax divided by a square plus b square into a sin bx plus c minus b cos bx plus c. So now we are going to replace these values. Yeah, so now we are going to write it as a sin bx, right? So minus alpha sin sx minus b cos bx, so s cos sx from 0 to infinity. Here the value of c is 0, so we are not writing it. So now again in this case we are going to take 1 by alpha square plus s square outside, and e power minus alpha x as common for both these terms, so it will be minus alpha sin sx minus s cos sx, and the limits are from 0 to infinity. So now let's apply the limits. E to the power, the upper limit is infinity, so it is e to the power minus infinity, x is replaced by infinity, and infinity into anything is again infinity only, into the brackets minus alpha sin infinity minus s cos infinity minus e to the power, again x is replaced by 0, lower limit again it is e to the power 0, minus alpha sine 0 plus s cos 0. So here e to the power minus infinity is 0, so this whole term is 0, and sine 0 is 0. So the remaining terms here are 1 by alpha square plus s square, minus into minus is plus, and e power 0 is 1, and s into cos 0. Here cos 0 is also 1, so the remaining term is s. So the final answer which we get is s by alpha square plus s square. See, there is no much difference in the answer which we have got here and here. Here in case of Fourier cosine transform, here in the numerator we have alpha, and in sine transform in the numerator we have s. Okay? Yeah, so this was one problem. So we are going to solve one more problem in this session. So I'll get you the question. So this is your second question, that is we need to find the Fourier cosine transform of the function f of x, which is given as e to the power minus ax. Also we need to evaluate the integral from 0 to infinity cos kx divided by x square plus a square into dx. Okay. So now for this we know that first we need to find the Fourier cosine transform of this function, and whatever we got it as the Fourier cosine transform, with the help of that we are going to find its inverse Fourier cosine transform, so that we reach the evaluation case which we are required to do. Okay. Yeah, first thing we are going to solve is the Fourier cosine transform. It is given by fc of f of x is equal to 0 to infinity f of x cos sx into dx. So now f of x is e to the power minus ax cos sx into dx. So again this is of the form e to the power ax cos bx plus c. So now let's directly write the answer, that is e to the power minus ax divided by a square, and in place of b there is s, so s square into a cos bx. So in place of a there is minus a cos sx plus s sin sx, b sin bx, and c value is 0. So and the limits are from 0 to infinity. Again in here we are going to take 1 by a square plus s square as common, and e to the power minus ax as common for both these terms, minus a cos sx plus s sin sx. Limits are from 0 to infinity. So now let's apply the limits. The upper limit is infinity, so e to the power this becomes minus infinity, minus a cos infinity plus s sin infinity, s sin infinity into the lower limit is minus e power 0 minus a cos 0 plus s sin 0. So here e to the power minus infinity is equal to 0, so this whole term is 0, and sine 0 is 0. So the remaining terms are 1 by a square plus s square into minus is again plus, e power 0 is 1, and a into cos 0. Cos 0 is again 1. So the remaining term is, so the final answer we get is a by a square plus s square. Okay, so now with the help of this a by a square plus s square, we are going to solve the inverse Fourier cosine transform, so that we are going to get this answer. Okay. Yeah, so we need to evaluate this. For that, use the inverse Fourier cosine transform. The formula is fc inverse of fc of s is equal to, the formula is given as 2 by pi from 0 to infinity fc of s into cos sx, since it's a cosine Fourier transform, so cos sx, and the parameter here is ds. So this is also equal to f of x, right? As per the definition, Okay, so now we are going to replace this by f of x. So we can directly write it as f of x is equal to 2 by pi from 0 to infinity fc of s cos sx, and here the parameter is ds. So but in the given question, we have the question in the given, it is given that f of x is equal to e power minus ax, right? So now directly we are going to write the value of f of x, that is we are going to substitute here it as e power minus ax is equal to 2 by pi 0 to infinity what just now we have got the Fourier cosine transform, that is a by a square plus s square, right, cos sx into ds. So now bring this 2 by pi to the other side, cross multiply. So this would be pi by 2 into e power minus ax is equal to 0 to infinity a by a square plus s square cos sx into ds. If you observe carefully, in the evaluation case we need only cos kx divided by x square plus a square. So we can see that we have here cos sx and a square plus s square. This a is disturbing us, so we can consider this a as constant and we can take this to the other side. That is, if we take this a first outside the integral, that is a into 0 to infinity cos sx divided by a square plus s square into ds, and now take this a to other side, that is pi by 2a e power minus ax is equal to 0 to infinity cos sx divided by a square plus s square into ds. Okay, so now we need to make some changes in this equation. Now in this equation, that is we need in the numerator, in the evaluation, in order to evaluate we need cos kx, right? Cos kx we need, but in the numerator we have it as cos sx. So now first we are going to replace the value of x. X is equal to k. Okay, in this case, in the whole equation, now we are going to replace the value of x is equal to k. So now what would the whole equation become? Pi by 2a e to the power minus a, and now x is replaced by k, right? Now it will be e to the power minus a k 0 to infinity cos s, and the value of x here is k divided by a square plus s square into ds. Now the answer is not done yet. We need cos kx in the denominator. Now we have cos, we have k, but in place of x we have s, right? So now that's the only thing left here. So now since s is the parameter, right, so we can replace the value of s, that is put s is equal to x. So now finally if we substitute the value of s is equal to x, we get it as cos k. Now s is replaced by x divided by a square plus s square, so it will now become x square into dx, right, is equal to pi by 2a into e to the power minus a k. So this is your required answer for the evaluation. Okay, so that's all for this session. We have solved 2 problems, important problems. So in the next session we are going to solve few more problems. Thank you.